independent. So as, what is x again?
It's the independent.
Yes, but in the context, the span of years. So as the span or spans of 5 years, and we need an increase, or we need a change. Is that change increasing, decreasing? Wesley, you awake over there, buddy? Come on, man. Huh? I can't hear you. No, this is not 7. I told you to put this next to your graph. This is not one of the questions. I'm helping you practice interpreting slope and y-intercept. So right next to that graph is where I would put this information. So as the spans of 5 years, what? Increase, decrease, stay the same? How do we know it's increasing?
Because the years go up.
Not just because the years go up, the number is positive. Because that 1 is positive, the numbers are
Going up.
increasing. Right. So as the spans of 5 years increase by how much?
0.126.
Remember, hold on, the spans are still the 1, right? The 0.126 is the temperature. I haven't gotten to the temperature yet. So as the spans of 5 years increase by 1, now, so notice this is my independent variable. Independent comes first. Now I can talk about the dependent.
Wait, so when is it increases by 1?
Oh, I forgot the 1, my bad. Increases by 1.
And
Now I can talk about the y, the temperature. The temperature what?
the increase by 0.126?
There's one word that we want to include in there. Does anyone remember it? Typically. It is linear, right? But remember, is this going to actually hit every single point?
No.
No. So it's not exact, it's an approximation, it's a prediction. So it typically increases by 0.126
Degrees Fahrenheit.
degrees Fahrenheit. So you always start with that independent variable, you end with the dependent variable. And that's my slope. It's a rate of change, and so I'm talking about how things change. From there, what do we still need to talk about? Have I interpreted everything about this line?
The y-intercept?
I still need to talk about that y-intercept, right? What would the y-intercept be?
56.9.
The 56.9 is a part of 0, comma. Remember, the x value of a y-intercept is always 0. The x value of a y-intercept is always 0. Brooklyn, have you taken any of these notes? You taking this down? Yes, sir. Okay. So 0, comma 56.9. This is again where it's important to have your x and your y defined. This 0, is that x or y?
X.
And x was what again?
The span.
Span of 5 years, right? The 56.9 was y then, which is our temperature. So, we're not talking about changes or anything like that, but at 0 what?
Wait, what is it? Wait, when it's all, when is the x always 0?
At the y-intercept. So remember, we have our 56.9, that y value of the y-intercept, the x value is 0. So, at 0 what? Go to your context. Not rate of change. What is x?
5 years. Span of 5 years.
It's at a span of 5 years, so at the 0, well at 0 spans of 5 years, which I know it sounds awkward, but I'm just talking about the x variable. at 0 spans of 5 years. Ezra, what are you doing, dude?
Nothing.
Pay attention right here.
I personally don't see what's funny.
Joey, hey. You also don't need to make comments on it, it's okay. I'm taking care of it. You're not done. Taking notes. This is supposed to go next to where your graph goes. So at 0 spans of 5 years, I've talked about my independent variable. What do I still need to talk about?
Dependent
The
variable.
dependent. 56.9 what? That's the, I think it's the average temperature, wasn't it?
The initial temperature.
Yes, hold on one second, let me check. Nope, that's not what I want. So it's the average temperature, is what it says, average global temperature. Right? So we want to say the average global temperature was, I will say we do need to say predicted. I won't hit you very harshly if you don't include that, but it is was predicted to be how much? 56.9 degrees Fahrenheit. Notice I'm just putting the context. Hear me very clearly. You're going to have to interpret the slope and the y-intercept. If you identify what x and y are in terms of the context, you're just putting the context there. Oh, thank you. That's the y-intercept, right? 0, 56.9 is the y-intercept. It's not that cold.
Why you had to go to what happened? You in
Okay. So, we now need to look at number 9, using your linear regression equation to predict the average global temperature. Note, we have a span of 5 years, right? 2032 to 2036. Which span is that? So we need to go back. Do we have 2032 to 2036?
No.
Nope. Okay. So we would have to continue this table going. So this, hang on, 2017 to, what that's going to be, 2021 would be span 13. 2022 to 2026 would be span 14. And we want, was it 2026 to
28.
No, hold on. Oh, 2032 to 2036. Okay. 2026 to 2031 would be span 15.
Wait, Mr. King.
Yeah.
They never repeated it again on the span on the chart.
It's supposed to be 7. Okay. That's my bad. I just messed up. So, 2032 to 2036 would be which span? 16. I needed to identify that because X, my number of spans of years, is the, what's the I word we used earlier? It's in the word bank, guys, the word box. That's my input. So I'm going to substitute that value. In for X. Thank you. So 16th span. Right? So X is equal to 16. This is where you would just need to pick up a calculator. We're predicting, right? We're going to put what in for X here?
That equation.
Well, I'm using the equation, 0.126, that doesn't change. What is x though?
Times 16.
Wasn't that what we said x was? It was 16?
Yeah.
So times 16, then, yes. Thank you, the equation hasn't changed. So what does that equal to?
58.
58 point what?
Good job, baby.
96? 916, thank you. So, for 2032 to 2036, we would expect the average global temperature to be what? 916 degrees Fahrenheit. Don't forget, there's a context to it. That's the Y value. In the years 2032 to 2036, we would expect the average global temperature to be 58.916 degrees Fahrenheit. No, can't do that. Okay. Here's one more. Okay, really quickly. Do you see how this number, that 16, was outside of our data set? Yes? This idea is called extrapolation. This is a term that they have in the book somewhere, but I'm just going to make sure that you see it now. If you see that word extrapolation, that just means predict outside the data set. So we have an input that was outside the data set, so we are making a prediction. Do we know that that's what the average global temperature will be in 2032 to 2036? No.
We haven't had that yet.
Correct. That's the point of a lot of this, is that we are making a prediction outside of the data set. And that's called an extrapolation. Prediction outside the data set. Y'all, get a hold of yourself. You're not in elementary school, you're not in middle school. Step it up. Tonight, it ain't that funny. Alright. So, we're going to move on to activity 1.3 and get as far as we can with this. Notice what we just did is called extrapolation. Here in activity 1.3, they're using what word? Yo, it's bolded.
Interpolation.
Interpolation. Hey, Addison, I need you off your watch. I need you paying attention. So one of y'all get up and get it, because don't use your feet to move it, because that's going to scratch the surface. Okay. Notice it's interpolation when we're making predictions within. Predictions within the data set is called interpolation. Predictions within the data set is called interpolation. Yes, Maddie? The easiest way is if you know what those prefixes mean. If something is extra, it is beyond. Okay? So if you know that detail of extra, so like extraterrestrial means it's beyond Earth. Like terrestrial literally means Earth. So extraterrestrial means beyond Earth. Extrapolation, extra means beyond, so it's outside. This prefix inter means within, literally. So if it's an interpolation, it's within the data set. Okay? Does that clarify that, Maddie? Okay, so that's what you would want to notice. So number one says use graphing technology to determine the linear regression equation for the data and interpret the equation of the line in terms of this problem situation. So, use your technology, get the least squares regression line, and complete numbers 1 and 2.
Wait, what do we do again?
Complete numbers 1 and 2, dude.
But how do we do that?
How do you think you would do it?
I don't know.
Okay, why don't you look back at the previous activity or talk to someone in your group to see if you can figure out how to get that least squares regression line. I will point out, what are you doing, dude? Stop goofing around. Listen, one thing I will point out is this. If we want a least squares regression line, what if we always had to create? We had to put the data in the list and spreadsheets, right? And then do what?
Statistics.
And then we had to do a data and statistics page to create a, what's it called? Scatter plot. Does that give you enough, Joey? So you had to do lists and spreadsheets and then graph it on a scatter plot?
Yes, wait, do I make a new page, or do I put this information on it, then make?
You have to make a list and spreadsheets page first.
I've done that.
Huh?
I've done that.
Okay, have you put your data in there?
No, I don't know what to put.
Put your data in there.
This is the data, so you, one of your boxes will be the year, and the other will be the percent. So then you put all the other year and all the
Yes, ma'am. I haven't put it in yet. Yeah, I have it in my grade book, or my attendance book, I just haven't done it yet. I hear a lot of talking, which must mean that we are completely done with this. Is that right?
I'm still putting in my date. What am I saying?
You're not one of the ones talking, dude.
Literally.
Yes, sir. Hold on. Okay. Yes, Joey.
What do you after I put in the date?
Okay. So that's what I'm about to do. So I have my data in the table. What do I need to do next? Control down. I need to say that again. I need to create what?
Statistics.
Data and statistics page. What's going to go on the x-axis? Year. The year is the independent variable. And what's going to go on the y? The percent, or whatever you put it in as, so percent.
Oh, I'm sure.
Notice once again, and that's fine, it's whatever you want to call it. Notice once again, what shape do we see?
A line.
A linear shape, a line. Now I'm going to go through, and again, if I want the least squares regression line, I've got to do this every time. I've got to put my data in, I've got to graph my data,
You need the regression.
and then I'm going to go to regression and show linear. Now, I want to pause and I want to point this out. First off, you got that funky E in there, right? What in the world does that mean? So one of the things I want to point out is this. We did year starting at 2010. But that's a pretty big number, isn't it?
Whoa.
Yes? Huh?
Mine doesn't have an E.
Me neither. Yeah, I don't have them.
Do you have it just as a decimal in there?
Yeah.
Yeah. Oh. Because mine made it into a decimal and yours didn't. So instead of doing that, but what I will point out is you're adding a very negative number regardless, right? That doesn't make a ton of sense contextually. if we were talking about 2010 as the initial year, what's another number I could have used instead of 2010?
2009.
Not 2009, not 2000s, but what one number, like before I hit start on a stopwatch, what number is there?
1.
So before I hit start? 0, right? So what could I put in the place of 2010?
0.
Alright, so go back to your stuff, and instead of 2010, put a 0 there, then a 1, 2, 3, 4, 5. Alright, so you should have 0 through 5.
Huh?
So 2010, we're making year 0. 2011 is year 1. 2012 is year 2. 2003 is year 3, meaning that these are the years after 2010. These are the years after 2010. Okay? So now, go back to your graph. Notice you don't see anything right now, do you? So click on year again. It'll allow you to change your variable, and click back on year, and it should fix it.
Also, year stacks.
You click year and go back to year. Well, it's not even necessarily that. I'll make sure that it doesn't give it to you on an assessment. Okay? So, there is my equation, my least squares regression line. Actually, that's not just mine. That should be all of ours, right?
Yeah.
Mine looks different.
Joey, yours doesn't look like 5.57x plus 4.9?
Mine says 5.57 equals 3 times that.
Okay, Joey, again, it just has more decimals, dude. It literally starts out 5.57, doesn't it? It just has more decimal values. That's fine.
But I don't understand why.
Because the calculator is set up that way for yours. I can change the settings. I'm not saving the time now. Stop stressing it. It just has extra numbers. That is a more accurate answer than what I have.
Good afternoon, Coco.
So, you better pause. You better make sure your equation is written down before you continue. What was it? 5 point what? 57x.
On Monday, December 26th.
Then what?
If you're interested in trying out for the full vaccine, take a minute and review the vaccine by this Friday.
I need y'all to hear me very clearly on this. You will have an understanding check tomorrow. Tomorrow is, listen, the last day that we are learning this. We will wrap up, pause, and stop hacking. You will finish this activity. We'll work through these problems, and then you'll have an understanding check before we move on. But I need y'all to focus. We have spent entirely too long on this activity, and I know some of it's difficult, but some of it's because people are not engaging and talking. We are going to wrap this up tomorrow. We're going to do an understanding check. So what should some of us do? You need to make sure you study. You need to know how to use the calculator. You need to know, listen, hey, stop and listen. You need to know how to use the calculator. You need to know how to write the equation of a line if given a graph or a table. You need to know how to calculate slope if given 2 points. And you need to know how to substitute in and calculate a residual. So be ready for that. We'll do a little bit of practice before the understanding check tomorrow. But you need to study. But it needs to be more than just I didn't mean to. Please be intentional about protecting this stuff. Is that your paper down there? It's not even for my class, dude.
It's not mine.
It's not yours at all?
Oh, yeah. Everything,